In this demonstration, we will give you an overview of Celsius, which is Integrated's full 3D thermal analysis package. And in order to demonstrate some of the features of Celsius, we've constructed a simple model. It consists of a spherical shell of glass, which is filled with glycerin, and which contains a static volume heat source. We'll use this simple model to illustrate how you go about performing a Celsius analysis, and also showing you the kind of post-processing analysis features that you can use with Celsius. In this view, we see a solid rendering of the spherical shell, and we've prepared actually a cutaway model so that 1/4 of both the shell and the internal glycerin filling have been made invisible, and that way you can see how the model is constructed. Now, performing a Celsius analysis is much like working with any other integrated program. You first create some kind of geometric model. In this case, it's just concentric spheres. And then, having constructed the model, you proceed to assign physical properties. For instance, we have assigned here the materials. In this case, we can inquire on the different physical properties. For instance, if we inquire on the interior regions, we have that filled with glycerin, and the exterior shell is filled with glass. Now, in addition, we have assigned a volume heat source. We can see that by selecting from the physics menu volume heat and display, and you can see the volume heat has been assigned. Now also, we've assigned boundary conditions to the outer surfaces. We can see that by going to physics, boundary conditions, and display, and we've used a convection boundary condition. Okay. Now this is a solved model, and we can look at different features. In this case, we plotted temperature contours on the cutaway surfaces here. You can see the highest temperature is at the center of the sphere, represented by the dark red color, and as you proceed to the exterior, the temperature decreases. We can also get a more qualitative idea of the temperature by performing a plot of a graph going through the shell and the sphere. So we'll go right from the top all the way through to the bottom. And this will plot in autograph the temperature distribution. So you can see that inside the glass, the temperature is starts off at the boundary at about 69 degrees and increases, and then once you get into the glycerin, the temperature reaches a peak right at the center of 258 degrees Celsius. We can also plot the Q field in terms of an arrow plot on the exposed surfaces. And again, as you can see, the magnitude is color-coded. The maximum value of the Q field occurs just at the boundary of the glycerin and glass interface. In addition to static analysis, we can also perform parametric analysis where we vary different parameters, such as, for instance, the radius of the sphere, or the materials, or the volume heat source. In a later video clip, we actually build this model so you can see how you could construct this yourself in Celsius.